Step 3, making our calculations. In each of the 2 previous chapters, we've had 3 calculations. Some measure of variance, followed by some measure of error, followed by some t. We have the same 3 today. First variance, then error, then our t. So the first calculation we need to make in step 3 is for sample variance. Remember, that's the definition of a t-test. It uses sample variance in place of population variance. But this symbol would indicate the variance of raw scores. For this, I'm going to put this D down there again for different scores. It doesn't officially need to be there, but I'm trying to be as clear about this as I can. So it's the variance of the difference scores, not the variance of the raw scores. Again, once we have different scores, we don't care about raw scores. But the formula for variance is the formula for variance. For sample variance is sample variance. So it's sums of squares of different scores divided by the degrees of freedom of those different scores. So your sums of squares, you either have that in the prep work that you calculated yourself that I showed you, or the problem just straight up gave it to you, or degrees of freedom, and the degrees of freedom. We know that from step 2. Again, it's the number of people minus 1, or the number of difference scores minus 1. Make sure you don't confuse that up there. Once we've got that, we've got our variance, our sample variance for difference scores. After that, as always, we need a calculation of estimated standard error. How much difference should I expect between the 2 different sets of data based on random chance alone? Well, in chapter 9, the symbol looked like this. The sample error of a sample mean compared to the population mean it came from. But I don't want the mean of raw scores, I want the mean of difference scores. So this symbol actually has double subscripts. It's S sub M sub D. But it still is pronounced estimated standard error. And it measures basically the same thing, and so the definition is the same. And as you're going to see right now, the formula is basically the same. It's just the symbol change to denote we're working with different scores instead. So, as always with our error, we have our variance divided by sample size. So, take the variance from the first calculation, divided by the full sample size. Now remember, not n minus 1, the full sample size. Divide that, then hit your square root, and you have your estimated standard error. And then the last thing we need is our t-statistic. In some ways, this mimics what we said in chapter 10. There's the formal way of writing it, which is comparing the sample mean of different scores against the hypothesized treated population mean of different scores, divided by estimated standard error. Well, just like we saw in chapter 10, this part right here is predicted by the null to be worth 0 points. So just like chapter 10, this is always going to be the sample mean of different scores minus 0. It's another statistics appendix. It's there, but it doesn't do much for us, and we can remove it, and it won't hurt anything. So we don't need to worry about that. All we need is the sample mean of different scores, which again has either been given to you or you did in your prep work, divided by the error you just calculated here in the second calculation. So basically the same 3 calculations that we've been doing now for a couple of weeks. And then lastly, I'm just going to continue over here. Step 4 is always the same. We make a decision. So we're either going to reject the null, or we're going to fail to reject the null. Those are our only 2 choices. And as always, if our t-statistic is located in the critical regions, lands in the shaded areas, one of the tails, we reject. If we miss and we land in the body, we fail to reject. And then writing this in APA is exactly the same as it's been for the last 2 chapters. No change here at all. Again, this is just the generic template. Don't copy what this looks like exactly. A T of whatever your degrees of freedom is. Same value that would be there, same value from step 2. A T of degrees of freedom equals whatever you computed. Again, this is your obtained T statistic, the one that you calculated, not the one you looked up. Semicolon P less than if you rejected, greater than if you failed to reject, and then finish it up with the alpha level, 0.05 or 0.01, whichever level you were running the test at. So with that all in place, in the next piece, we're going to walk through an example. I'm not going to use one of the ones from the back of the book. I don't want to burn you out of your chance to practice homeworks. So I'm going to put a different problem up here on the board that we can work through together.